Today we're gonna learn about support reactions. Before that, we're gonna review some about the external loads, which we studied last class. Okay, how many types? First is a point load, a load applied on the point. Linear distributed load or load applied along the line. Surface load or the load applied on the surface. Body force, or we can simply understand as weight. Okay, 1, 2, 3, and 4. And then today we're gonna learn about support reaction. This one, support reaction is that the force that develop at the support. Okay, we have many types of connection at the support. Okay, let's consider it one by one. Okay, first cable. Okay, we have cable here, cable. If we cut the cable to find the force at the support, the force will direct along the cable. Okay, so the cable, if we consider the support reactions, the force that apply on the cable is along the cable. The second one is roller. The roller, we have only force act along y directions. Okay, roller. Smooth support. Okay, if we consider the reactions, the force will act perpendicular to the surface or make an angle theta with the vertical axis. Okay, and the pin will exert Fx, Fy if we consider support. The last one is the fixed support. We will have Fx, Fy, and couple moment. Fx, Fy, and couple moment. Okay, to understand it more clearly, we will consider about general rule. For general rule, if the support prevents translation in a given direction, then a force must be developed on the member in that direction. Or if rotation is prevented, a couple moment must be exerted on the member. Okay, so let's say it again. Cable. Okay, like a rope. If we cut the cable, we see the force along the line, and then it's a pipe outward. Okay, roller. The roller, if you see it, you can move along x directions. You can rotate it. So if you can move along x, so no reaction force along x direction. So if you can rotate, we don't have any couple moment. But the roller will prevent the motion along y direction. When you push this force, the roller will make reactions along y directions. So the roller you can move in X and can rotate, so no prevented force along X or no prevented moment for this roller. So if you cannot move in which directions, the prevention of the force of the reaction will generate at that direction. Okay. For the smooth support, okay, prevent the motion along the normal directions perpendicular to this surface. Okay. For pin, if you consider pin, you cannot move in X directions or move in Y directions, so but you can rotate it. So if you cannot move in X or move in Y, we will have Fx because cannot move in X. We have Fy because you cannot move this bar along Y directions, but you can rotate it, so no need to have couple movement. Okay, for fixed support, in the easiest case, can you move in X directions? No, you can't. Can you move in Y directions? Can you move in Y direction? No, you can't. Can you rotate it? No, you can't. So if you can't rotate it, can go in X, can go in Y, so we will have a force Fx because you cannot move in X. We will have a force Fy because you cannot move in Y directions. And you can rotate it, so you have a couple moment here. So this is the way to consider the reaction force and the support.